If our data is continuous, then a line graph is a good choice. Why? Because a line graph has predictive value beyond just your measurements. What do I mean by that? Well, let's look at this example to understand. Here we see a graph representing the data for the question, how does amount of wind affect evaporation rate? So we vary amount of wind and we see how that affects evaporation rate. How do we vary amount of wind? Well, there are different ways to do it, but one way would be that we have a fan and we place some water in Petri dishes at different distances from the fan. We can place some Petri dishes at 0.5 meters from the fan, half a meter, and then some more at 1 meter from the fan, and then at 1.5, and then at 2 meters from the fan. And those that are close to the fan experience much more wind than any of the others. So the further from the fan, the less the amount of wind experienced. Distance from fan is an indicator of the independent variable amount of wind. Right, so now in each of those Petri dishes, let's say we place 10 milliliters of water. Then we leave all of that for 2 hours. We come back after 2 hours and we measure the volume of water that's left and then do a simple subtraction to find out how much water evaporated in those 2 hours. And here we plot our data. So we can see that the average of the amount of water that evaporated from the Petri dishes half a meter from the fan was about 9.5 milliliters, and so on. And each of these 4 points is our plot of our data, meaning that is what we measured. Now, to that, we add a trend line. What is the purpose of that trend line? That trend line predicts what values we would have measured at the values in between the ones we did actually measure. So, for example, from this, we predict that had we placed a Petri dish 0.75 meters from the fan, then approximately maybe, 8.7 milliliters of water would have evaporated in 2 hours. We didn't actually place any Petri dish at that distance. So the line is just predicting if we had. Now you have to realize that every reading that we ever take, any data, will always have some experimental error in it. Maybe the fan wasn't pointed exactly correctly at the exact right angle for that Petri dish, but for that one it was, and so then we get a little bit of inconsistent readings, or maybe we measured slightly incorrectly. It wasn't quite easy to measure some of the readings perfectly accurately. Then you see our readings are not going to be the truth. But now our line is trying to represent the truth as best we can and trying to ignore that experimental error as far as possible. Nature tends to have smooth relationships between variables. So if we want that line to represent the truth as closely as possible, the truth is most likely to be a smooth relationship between variables, so we should make that line smooth. So we mustn't go dot to dot to dot, really emphasizing our measurements which have error in them anyway. Rather, we must go smoothly, sometimes having to go between dots, maybe a bit above or below some points, and then probably that's more likely to represent what nature really is like. Can you see now why you certainly cannot draw a line graph for data that is discontinuous? It must be continuous data because the purpose of that line is to predict the readings in between the values that we actually measured. But if there cannot be any values in between what we measured, then of course that's meaningless. And that would be the case with discontinuous data.